All right, we're live, everybody. Okay, so welcome to Group 9 judging. We are the last group of MarketMake, but last but not least. MarketMake's been an amazing event. It's our first event of 2021. We're really excited to be running this alongside with the Aave team. And of course, we have Jordan from Aave here as well, helping out on the judging side. So we're really excited about that. Quick little summary about the event. We had 490 hackers join us. Those hackers are, of course, across the world, 58 countries and 17 time zones, which is basically every habitable time zone on Earth, which is always cool to see and always fun to schedule for. Really great event. Really excited about the project quality. We had 120 projects around that number come out of this. Today, we're going to see about a dozen of them come through as part of this demo presentation here. And just kind of give you a sense of sort of what to expect over the next maybe a couple hours or so. So the judging format, everybody has prepared a 4-minute video demo, up to 4 minutes. So we'll spend time for the video demo. You'll play that video. Of course, everybody here has been through the green room already and kind of knows the deal. After that, we'll pause for 4 minutes for questions. So the judges can ask one-on-one questions to the teams. We'll have a nice question period there. And then we'll take a 2 to 3 minute break every 4 teams, give the opportunity to kind of stretch your legs. Judges can chat a little bit about how projects are going if they have the time. And halfway through, we're going to take a 10-minute break, again, to sort of stretch legs, let the judges get together and kind of hash out how things are going so far. And we'll carry on from there. So wanted to briefly touch on some of the judging criteria that our lovely judges will be going over. So we have 5 different kind of ways that we judge projects. So technicality, so how technical a project is, how difficult it is to actually build. Originality, so this is kind of basing on the idea of the project. How original is it? Has it been done before? Is it really useful? Is it interesting? Practicality, that's kind of definitely more the useful piece. Is it going to be something that's going to be used in the ecosystem? Is this something that's really reasonable to have as part of the Ethereum ecosystem and DeFi in general? 4th category is UI, UX, DX. So sort of what does it look like? How does it perform? Kind of how are those flows feel? Is this going to be a product that kind of anyone can use, or do you need to be really specific? And then kind of a catch-all category, the wow factor. So it's hard to judge everything based on only 4 categories. So if you're blown away, the last category is the wow factor, which helps sort of capture things that otherwise cannot be captured in those other 4 categories. The intangibles, if you will. So a couple important notes. I mean, this has been the case since day 1 of ETHGlobal. So, this isn't a competition, right? So people are here to learn. We're going to have a wide variety of projects from people who are experts and people who picked up crypto or DeFi or blockchain for the first time ever. So we're not all playing on the same field, and that's important. Everybody's learning, and we're all looking to grow as both an ecosystem and personally as we build and learn new things. These projects also aren't necessarily built to be businesses. They're built to be interesting ideas and interesting ideas executed on. So it's important to realize that they might not come with a business plan, and that's okay. Also, it's blockchain, so it's definitely okay. And also, hackers are here to get feedback, right? So this is meant to be sort of a step in the milestone of taking that project to complete fruition. This is a great way to get feedback from industry experts and also show off what you've built in such a short amount of time. Last but not least, big thank you for the 3 people on this call that are spending their Tuesday morning with us, or Tuesday afternoon or evening with us. So we have judging with us, we have Jordan from Aave. We have David from many things. I put on this list just DeFi 777. And then we have Dmitry from Bollinger Investments. Okay, awesome. So with that being said, that's the end of my presentation. I'll jump into the demos, and we're going to start with team Aave Wasabi. So if you can raise your hand, which I think you already are, we will promo you to the stage, and you can click the computer share audio button and share your video.
Guys, are we supposed to see anything right now? Because I'm not seeing.
I think Jackie's still trying to join.
Oh, okay, okay. I was just wondering.
Yeah, me too. There we go. Okay, cool. Looks like we've got that all set up. We can see everything. And also, I'll turn it over to you, Jackie.
Hey, I'm Jackie, and this is for Aave Wasabi. So what is it? In a few words, it's markets to buy and sell risk. What does this mean? As an example, say we have someone who wants to open a highly leveraged position. At 4x, 5x, 6x leverage, it's a good idea to hedge your position. With the protocol, we can do this. In the worst case, if there's a huge loss, the protocol will be able to cover some of it. In the best case, there's a profit and both buyers and sellers share in it. More concretely, in its current iteration, we just use the protocol like we use the liquidity markets in Aave or Compound, with borrowers being the sellers and lenders being the buyers. Now here's a demo of what I've gotten done. In this scenario, we have a deposit that represents some users who just want to get the yields. Next, we have a deposit that represents users that are leveraged going long on ETH. They take out enough USDC to enable loss coverage. In my terminal here, I'm artificially collapsing ETH price, prompting the users to close their position at a loss. Now, when they repay their debt to unlock their collateral, the protocol allows them to pay less than they need to unlock and withdraw. So what's going on? All deposits in the protocol are actually deposited into Aave, and the borrowers come from Aave too. Lenders get Aave's yield with the loss coverage and profit sharing subtracted and added, while borrowers get Aave's interest and the protocol's loss coverage and profit sharing on top. Once a position is closed, we either reduce the borrower's debt or increase it based on whether there was a profit or a loss from the prices at the time the position was opened. The rates for this are determined algorithmically based on supply and demand. For example, at its core, the cover rate is simply the solution of the constant product equation. The properties of this curve incentivizes opening positions, but rates quickly decay as demand increases to maintain protocol solvency. You can learn more about this in the documentation. So what's next? More analysis on the protocol rates, lots of safety improvements to be able to handle real money, moving away from borrowing and lending terminology for general risk markets, like for more complex risk packages like pooling leverage. That's my time, thanks.
Very cool.
So about 4 minutes for questions from the judges. And Jackie, if you're able and you want to share your video, that's always better.
Oh, hey, sorry, my webcam is having issues. Can't share my video.
No worries, no worries.
Who wants to kick off? I guess I could. Great job. I think leverage is something that we know has product market fit in crypto. So it's interesting that you're kind of building with that, and I think this will probably find some interest with your typical DeFi user. I'm curious, what's the difference here between just using less leverage instead of just selling off a portion of that leverage?
Sorry, you're asking what's the difference between this and using less leverage, as in just not making such a risky position?
Yeah. So it's like you're hedging a leveraged position, and how is this different from just taking less leverage in the position in the first place?
So with higher leverage, you have greater profit, but if you take less leverage, you obviously get less profit. So if you take higher leverage, you get more profit, which you can share with the entire protocol.
Got it. So you are keeping the same upside, but you're capping your downside, or are you also capping your upside here?
So if you make a big profit, you do share some of that. So you are taking less profit, but the idea is the risk is mitigated, but the profit is, it's not the same, but it's higher than you would have if you had less leverage. But with the protocol, you still have the same sort of like upside, but with less risk.
Got it.
That makes sense.
Yeah. Awesome. Thank you.
Awesome. Yeah, if I can go, I was just wondering, like, how do you plan to incentivize the other takers, the one that are like basically helping you to hedge the risk,
So if the people that take out positions to leverage, they share some of their profits, so that goes on top of the yields that you have. So if you're a supplier and you expect like ETH to go long, then you're expecting people to leverage, and then you expect them to profit from that. So there's also like a short pool, and if you expect the ETH price to go down, then you would supply in a short pool, because that's where you expect where more yields would come from, people shorting ETH.
Yeah, okay. It makes
And so
sense.
those lenders get that share of the profit on top of the existing Aave yield. You said, right?
Yeah, but you have to make sure that if you're lending on the long pool, like you're fairly confident that ETH is going to go long. If you're lending on the short pool, you're more certain that your ETH price is going to go down. So you have to be careful about where you put your liquidity, your capital.
Gotcha.
Awesome. Yeah, that's amazing.
Mm-hmm.
Thank you.
Cool.
Very cool.
Oh yeah, just one more question. Who did you build this with?
Solo projects, my first time. I wasn't very confident going into this, so I thought it'd be better if I just didn't try to make it too complicated or like anything like that.
Yeah, no, you have to start somewhere.
Yeah.
Awesome. Good job.
Thank you.
Awesome. Thanks, Jackie. Very cool. Solo hacker, first time. Love to see it. Okay, cool. Up next, we have team DethLock. So he's promoting them now. Welcome, team. Thanks for sharing. Awesome. I'll turn it over to team DethLock.
Oh,
Doesn't look like the sound is coming through, so you'll need to reshare with the share computer sound button toggled.
Hello, we are Team DethLock. We are a premier app development team focusing on simplicity.
The video isn't showing up
DeFi
anymore.
brick that adds time-released ownership anywhere in the DeFi transaction stack. In DethLock, a will owner can deposit raw Ethereum or a token ownership into the will structure.
We're not seeing the video.
Owners can continue to deposit or
The audio is coming through, but it looks like you shared the wrong window on that one.
We are a premier app development team focusing on simplicity. DethLock is a simple DeFi brick that adds time-released ownership anywhere in the DeFi transaction stack. In DethLock, a will owner can deposit raw Ethereum or a token ownership into the will structure. Owners can continue to deposit or withdraw from the will at any time. After a deadline, a beneficiary address can also withdraw. So here we have the scaffold sketch of our front end. On the left is our deployment address standing by with the wheel creation page. On the right, we have the second address watching our wheel management page, which runs on top of the graph. We begin by creating a wheel by copying our intended beneficiary address. Then we choose to deposit 1 Ethereum into our new wheel. We could also deposit any number of tokens from the list of our usual suspects. We've also deployed stooge tokens for use in local testing. We'll choose to deposit 0 Larry coin into this wheel. We can select our wheel's deadline from this handy pop-up calendar, or for handy testing purposes, we've created this now plus 1 minute button. When we press the create button, the wheel is initialized and caught by the graph management screen listed under all wheels. We will switch the owner over to the manage screen and the other address over to the create tab. Now we will create a second wheel with the address roles reversed. We'll set the deadline out a bit further and deposit some curly coin this time, along with another F. We've an all wheels refresh issue to tidy up, but with some poking, everything does display correctly. Next, we'll test the owner update function, which should always work. Here we shorten the deadline to something a bit more lively. Our first wheel's minute is up, so now we can claim funds from it. We observe our beneficiary funds increase by the 1F and the claimed wheel balance drops to 0. Wheels are immutable, so the structure remains inactive or active forever for further management. We still have a front-end update issue on the left management screen, but a bit of poking resolves it. Our owner withdrawal function does in fact work, but our graph refresh needs some work. Our scaffold React front end is still notional. For example, here we have the proxy interface showing the textbook design patterns, ownable, pausable, and something I call accountable, meaning it tracks loose ether sent to its address as tips and makes it available as salary to the owner. Future work obviously includes finishing the front end, unit testing, and deployment up the chain towards the main net. Team Locked would like to thank you for your time and consideration. We look forward to seeing you all around the developer community.
Amazing. Feel free to share your videos if you're comfortable with it and turn it over to the judges for questions.
Very cool, guys. Looks like this was built with Scaffold ETH.
Yes.
How did you guys find building with that? Did that kind of simplify the development process a lot?
Yes and no. The learning curve was kind of steep. It was a new tool for a lot of us.
Okay.
But once we got it, there was a lot of Legos in the box to play with.
Hi.
Nice, nice.
Yeah, so if I can ask the question, or David, you
Go ahead.
Yeah. So thank you. I was wondering. So you basically want to push people to lock, like, so they don't basically like you put a timeline on the locking of assets. And I was wondering, like, did you think about, for example, depositing some assets in Aave so they can earn interest while they are locked in the DethLock? So let's say that you put a lock on 10 years, might be interesting, even like if on lending protocols, the ETH rate is not that great. On 10 years, it's still like a very interesting, or even like if you put stable coins, for example, like could be interesting to consider.
Yes, we were considering depositing on assets on Aave. We just didn't have time to implement that.
Okay, yeah.
Cool. Yeah, in general, I really like the direction of the project here. I think, you know, going cross-chain and having bridges is important. So great stuff with the direction. I'm curious in general, what was the hardest part about building this business?
Well, we are a premier team. We were just here to survive the hackathon and see what it's all about. So we will come back with a more complex project next time.
Cool. And with this one, it sounded like it was pretty straightforward for you guys, or was there anything that you thought was relatively complex?
Solidity was straightforward. The front end, we had a ringer whose career wouldn't let him participate, so we had to wing it on that. We were hoping for more.
Yeah, well, I think it's a good first step for sure.
Just one more question about the contract. So each will have a single owner that has to kind of do that keep alive?
Yes, each will tracks one owner, one beneficiary, and one token.
Okay, and can the will owner withdraw early?
Yes, and
Yeah,
even
okay.
late.
And okay, they can withdraw at any time. Gotcha. And they are the one that has to send that keep alive message.
Yes.
Gotcha. Might be cool. I don't know if this is something integrated. It might be cool if that could be separate accounts, because you might want like a cold storage account to kind of that has access to the funds in a separate one where you can like send these keep alive messages.
There are several applications we've thought of, and that would be one of them. Just mixing and matching where the addresses are coming from and going to. For
Awesome.
example, key recovery if you are your own beneficiary.
Yeah, that makes a lot of sense. Cool. Well, very cool. Thanks, guys.
Yeah, great job.
Thank you kindly.
Awesome. Thank you, Team DethLock, sorry. All right, next up, we've got Team SimpleFi. And let me just find Raphael. There we go. Promoting you now. Okay, Raphael, when you're ready, feel free to share your screen, tick that share computer audio button, and we'll be off.
Hi, I'm Raphael, and this is SimpleFi, my MarketMake project. All right, so the problem that SimpleFi solves is that it's really hard to keep track of your DeFi investments, right? We've all been there. We've all seen like this crazy opportunity that's offering 100 or 200% MPY. We ape into it, we put in our money, and then we look back a week or 2 weeks later, and we've actually lost money, and we wonder what's going on. And that's when you can actually calculate it. Sometimes it's just really hard to figure out what the return has been. And if you're like me, sometimes you even forget where you've put your money. So the solution is SimpleFi. It's just a one-click tool. You connect your account and it will show you exactly what you own, so the underlying assets that you own, how much money you've made, and it will also allow you to combine your returns from different fields and different strategies. Okay, so welcome to the SimpleFi homepage. This is where you can connect your wallet via MetaMask or literally just check any Ethereum address. So we'll do that. We'll just look for someone who has ADAI that could be a good test subject. So let's look at the holders here and just choose someone randomly and plug that address into SimpleFi. SimpleFi is going to look at their investments, rewind their positions, and then show us the combined ROI of these 3 investments that they've made. So 2 earning fields, so liquidity provider, 1 farming field, and in total they have 5 tokens that they're holding, of which 99% are invested. So we can check here what those tokens are and see that there's a bunch of DAI, but also some USDT, some USDC, and we can see that a lot of these tokens are actually fully staked or provided as liquidity. So we can see where they've been provided as liquidity. The first one is obviously in the Aave DAI deposit pool. So click on that, we can see the ROI, and we can also see that there's part of it that's in the Curve Aave pool, which is great. And here we can not only see the ROI from this field, but also we can see if there are any yield farming fields that are related to this one. like for example the curve rewards gauge, then we can add the farming ROI on that and see the total ROI from those two related fields. So we can see that there's an ROI of $100 from just the core earnings, and that the farming on top is $619. And so if you combine both, that makes a much bigger ROI. And finally, we can just see details about the farming field itself. So that's the curve of a reward gauge. So there's 619 of unclaimed curve for the time being, for a total ROI of 2.48. The way that SimpleFi works is essentially a lot of data fetching. So some of it directly from the blockchain, some of it from subgraphs and CoinGecko and Etherscan. What SimpleFi will do first is scan for your surface investments, and it will then rewind that position to find what the underlying fields are. And then finally, it will boil it down to the underlying assets, which are going to be DAI, USDT, and USDC. And then using historical price information, it will then calculate your ROI based on your past transactions. Thank you very much for listening.
Wow, that's super cool.
That's useful.
Thanks.
I think this is like one area that there's just like countless opportunities for growth, because it's like one of the best things about like blockchain and DeFi is that you can have a bank and you can have other people build a UI for your bank. You don't have to use your bank's UI. That's super cool. One question I had was, I mean, I know that like this is a lot of data you guys are indexing, and it was cool the way you described the way you've kind of rewound that. I was curious, are you running any of your own, like how much of this happens on the client side versus the server side? And are you guys running any server side infrastructure, or is it just, you know, like the graph, as you mentioned?
Yeah, so there's a very simple backend that basically holds the contract addresses and things like that, so as not to clutter the front end. So yeah, but the rest is mainly on the client side. So some of it is pinging CoinGecko, some of it is pinging Etherscan, particularly for the token transactions, and then things like the graph are used depending on the protocol. So there's no need to use it for Curve, for example, because you can get most of the information from the controller gauge contract that they have, for example. But with Aave, the big challenge was that it's continuously updating the balances. Yeah. So if you're staking something, it would show on the transaction history that you're actually taking out more than what you had. So the graph is used to get the historical balance.
Gotcha. Very cool.
Nice. Yeah, this is great. I probably don't know where I put a lot of my money, so something like this would be very useful for me as a user. I'm curious. How do you, I guess, how do you support additional protocols, whether in the UI or in the backend? What does it take to include another protocol here?
So adding another protocol, it will depend on the protocol. So you have to figure out every single time what the methods are to actually go and query the balance. So balance is normally it's quite typical. It's just balance of, but then it's earning, and then sometimes you have to add the account address as well as the asset address when there are multiple assets, like in the curve pool. So it's just yeah, it's just about specifying those and switching them, routing them inside on the front end.
Mm-hmm. Got it. And then you would do that. I guess you just need to understand how that other protocol does that.
Yeah, exactly. And some of them are easier than others. Like Aave is great because the documentation is awesome. The subgraph, is like really clean. It helps a lot.
Thank you. I think it would be very useful. And I was wondering, actually, like, have you thought, or do you think it would be easy to get like a CSV export of your all the assets, so you can basically get like for even like tax purposes, so you could like have a direct like Excel sheet with all the things that you are putting in the UI, That would be actually very useful too.
Yeah, I think that would work. I mean, right now, I don't think you should trust exactly what you're seeing, but yeah, no, definitely, it could work.
Didn't use this to calculate my taxes yet.
Not yet.
Yeah, someday.
Yeah.
Awesome. Congrats.
Thanks.
Yeah, thanks, Raphael.
Awesome. Thanks, Raphael. Good to see you again. And awesome. We'll move on to the next team. So up next, we've got Team Polaris. So I'm going to invite them up right now. And I'm going to kick you back down, Raphael. Thanks again.
Thanks.
Okay, cool. Team Polaris, whenever you're ready to go.
This is the Polaris Group. We build blockchain games. Our team consists of 4 members, and I am JE. We're all students from Tsinghua University. So our project is a decentralized, transparent, and fair gaming platform utilizing the layer 2 solutions on Matic to lower the extreme high gas fees on Ethereum network to provide a quick and also affordable and fun gaming experience to our users. It also offers borrowing options using Aave's credit delegations to allow users borrow tokens from friends to play our games and return the tokens back to them after winning. So this is a summary of our project. We implemented a simple rock, paper, scissors games. It is 1 player versus the smart contract right now, and is deployed on the Matic network using the Matic layer 2 solutions. So it has extremely low gas fees when players play our game. It also has a P2P credit delegation feature using Aave's credit delegation. It allows users to play games without owning any tokens up front, and they can return tokens back to their friends after winning. Our long-term goals are using zero-knowledge proofs and to explore the possibilities of P2P interactive games on the blockchain, and also to enhance the privacy of our users' data. And we also want to issue our DAO token for governance. Next, we'll do a demonstration of our project.
All right, so here's our landing page. You can see our logo right here and a 1-sentence description of what we do. If you head over to the app page, this is where the user interacts with the smart contract, playing the rock, paper, scissors game. So you first need to configure your wallet to Matic, and you connect MetaMask to it. And you can simply make a choice between rock, paper, and scissors, and each round of the game is 10 Matic. So now I hand it over to Brian to talk about the Aave part.
So here we have the section for lenders where you can deposit your collateral, and then you can also withdraw it and then check the amount that you have deposited. And here's a section to delegate. And when you're delegators, then you can use this function where you have the delegatee's address and then the amount that you want to delegate to him, and then you hit confirm. You can also check how much you have delegated for with that delegatee. And as a delegatee or the borrower, you can just borrow the money and enter the amount and then the address of your delegator. And as long as it's within this allowance, then it should this confirm should work. So all of that was the Aave part. And after user borrowed the money, user can go play our lottery game, which is deployed on Matic network. Well, to solve the extreme high gas fee problem on Ethereum network.
Here's the flow of our project. You have Ethereum, and we implemented the front end that allow you to do borrowing and lending on Aave. And then you can use the money that you borrow or the ones that you have already to get Matic, and you can play the game on Matic. And then afterwards, you can transfer it back to Ethereum and hopefully win some money. So this is our project. We weren't able to implement all the features that we wanted due to time constraint, but we really enjoyed the time building this product, and hopefully you like it too. And thank you for listening.
Awesome. Congrats.
Cool.
Thanks, guys.
One quick.
Feel free to turn on your cameras. Sorry to cut you off there, David.
No worries.
And yeah, turn over for questions.
So one quick question I had was I was just trying to understand the difference between, so it's a lottery, but there's also the rock, paper, scissors. So is it if you win the rock, paper, scissors, then you earn the lottery, or how's that work?
Yeah, so our ultimate goal was to build a gaming slash betting platform. So we don't, we want to implement interactive games, but at the same time, we also want to implement a lottery, kind of like a lottery platform where users are allowed to make predictions on like esports games, NBA games.
Okay, cool. So you see this like scaling up to being like all sorts of different games, blockchain, sports, all different kinds of things in the same place?
Yeah, that's like what we want to build in the future. Like we want to add more features onto a platform.
Awesome. Very cool.
Yeah, so I picked up the betting part, and I was wondering, like, have you had the idea, or if this is something that you thought about to do, like no loss betting? So you use basically the interest generated. So you bet only the interest of your Aave deposit, for example. Like using the credit delegation is very good, but it's quite difficult to always find someone to delegate you credit. But if you could use only the interest generated from Aave to make those bets, it might be easier, or even like just delegating that interest, for example, that could be interesting.
Yeah, that's a good suggestion. And we also thought about implementing like a no loss lottery, like pool together. I don't know if you guys have heard of it. So where users just like pool money into the lottery and they get a ticket to be drawn in the next lottery to win the total money that we win from like the interest in the always lending pool. That's what we thought about doing too.
Yeah, that would be the case if we could kind of issue our own token and user can deposit their ether, and then we can issue our token, and then we can just put the ether into Aave to earn interest, and then that way is they could just it could be just a no loss lottery, and it's pretty good, and everyone wins.
Awesome. And how was it to build with Matic as well? Like you use the Matic USDC, the MA USDC built by the guys of Aave, or did you build like your own bridge to bring the assets there?
Can you repeat that question again?
Yeah, so recently the team of Aave, which is a previous actually hackathon project, they built a bridge Aave assets, so a token USDC onto Matic. And I was wondering like if you use their solution or if you build yourself.
No, we didn't use Aave in our project this time.
Okay.
Yeah, also, just the Matic token for no. Sorry, yeah, go ahead.
Oh no, I was just going to say this is great, and I think it makes a lot of sense to build on L2 with games. You know, just gas fees. The UX very pleasant on L1. If you had more, what other games would you like to implement here?
I think Blackjack is like a very popular game that everyone would know how to play, so that would be our other choice.
Cool. Sign me up.
Nice.
Do you guys have any other questions?
I think we're out of time, but thank you, Team Polaris. Really appreciate you demoing and great job.
Yeah, thanks.
Awesome.
Thanks, guys.
So great. So since that's our first 4 teams, we're going to take a quick 2 to 3 minute break. So judges, if you want to sort of stand up, get the blood flowing, reorientate yourself, feel free to do so. And we will be right back in a couple minutes.
Yeah, cheers. Coming back.
All right. Let me know if you're back, judges. And then in the meantime, Team DigiU.Lab, if you're in the chat, can you please raise your hand just so we can promote you? Like David, you've like completely changed.
I've traveled to a different place, across the apartment.
Crazy. Okay, last call for DigiU.Lab. If you don't raise your hand in a sec, we can just move on to the next team. It's just the button in the middle of your screen. It says raise hand. Okay, cool. We're gonna move on to Team ALKEMY. If you're here, please raise your hand. There we go. We got a taker. Okay, sweet. Promoting you now, Team ALKEMY. Okay, cool. When you're ready, feel free to share your screen with your computer audio sign ticked, and we'll let you take it from here.
We are Team ALKEMY, and here are the members of our team. Inspired by Vitalik's post on the need for social recovery wallets, we created a Layer 2 wallet that enables users to recover their seed phrase anytime, anywhere, in a secure, decentralized, and anonymous way. We need a better way to safeguard seed phrases. What differentiates us from other social recovery wallets is that our guardians are chosen randomly instead of by the user. Financial rewards have also been integrated to incentivize guardians to assist with seed phrase recovery for otherwise complete strangers. Here is how it will look for the user. Welcome to ALKEMY, the guardian of wallets. Our user will be prompted to log in by entering their password and importing their wallet. Once imported, they will be brought to the home page where 3 options will appear: protect a wallet, recover a wallet, and view stored wallets. To protect a wallet, you will be asked to choose a wallet, choose your level of encryption, and entering your master key. Once confirmed, your seed phrases will then be encrypted and sent to your guardians. Encryption complete. To recover your seed phrase, you will be asked to choose your payment method, entering your master key, and requesting recovery. Your guardians will then be alerted. They will then send your seed phrases to you.
Now that you know more about Guardians of Wallet, let's dive into the technical part. A user will be able to ask to store his password securely to the smart contract. The smart contract will retrieve all the guardians and choose randomly people who are gonna actually store your password. It's gonna return a list of the guardians plus their public key. You're gonna be able to split your seed phrase into multiple pieces, encrypt each of them with a master key plus a public key from each of the guardian. Once it's done, you're gonna send each of the guardian a piece of your password securely off-chain. You're gonna then be able to store your contact list or the guardian list into IPFS. The same goes for the guardian who has your seed phrase but has no idea who you are, because he's only storing an encrypted password, a piece of password, plus an alias that only you know. He will be earning interest for holding your password, and of course, every time you request your password, he's gonna get more reward, which is gonna encourage him to keep your password safe. Quick end-to-end test for our smart contract. You can always look at the code in the GitHub to know more about the application, and also we want to mention that we're gonna make sure that the guardians have the password, so we're gonna check in every month to see if they're still keeping your password so they can still keep their reward. So what happened here is an invitation has been sent to the guardian. The guardian will be able to accept the invitation, and we're gonna select random guardians. In this case, we're only taking one guardian into consideration. The seed phrase will be then encrypted with your master key, and then encrypted with the public key. Then sent to the guardian, who can then store it securely. At the same time, you can store the guardian list on IPFS. In order to request your seed phrase, you just need to call the smart contract and again contact all the list of guardians that hold your password by providing them with the master key, of course always encrypted with their public key, so it could be secure even if it's off-chain.
Awesome. Feel free to share your videos and we'll turn over to the judges for questions.
Sure. Well, I think this is awesome. I mean, beautiful wireframes. It just looks like you put a lot of time into this. So just great job. Did you guys build this in 3 weeks?
Yeah, it's gonna be, we actually still working on it. We even made some changes to the design that I wanted actually to talk about. For the guardians, actually, when they're storing your password, they're gonna have like a random reference that only you have. So even if somehow this guardian wanna go and check, oh, I have a piece of password, let me find someone else. So he's gonna find another person with had a random reference, only you know, and an encrypted password that is for him useless. And we keep adding layers of security to make it fully decentralized and more secure.
That's so cool.
Yeah, it's like 3 weeks, like no sleep.
It looks like that for sure. And then you're splitting. Are you using like Shamir secret sharing to split the keys?
Exactly. Yeah. So,
very cool. Sorry. So one question I had that you kind of answered in your videos was you mentioned that like we're going to kind of keep pinging the guardians to make sure they still have the passphrase. Is that like kind of a point of centralization at this point? And if so, is that something you plan to expand?
Actually, well, the user are going to pay for this service, right? We're providing him with a service. So in order to secure his password, I'm sure a lot of people is like, you pay for banking fees. So you're gonna pay either monthly or per year, and you can have like a small extra fees every time you recover your password to encourage more guardians to keep storing your password. The idea is also to go from IPFS to Filecoin, so to keep sure that the password is actually there. So we don't want it to disappear after a moment. So yeah, those fees are being paid by the user, and interests are actually there is extra reward that we're gonna put on Aave. Every time someone recover a password and it's confirmed, the contract confirmed, he gonna get like this reward, which is extra because we earn interest. So
yeah,
like
I think it's really some some projects. Like let me get this straight. So like I have the app and I get like randomly chosen to keep the password, like part of the password of someone else. And since I was chosen, I start getting like a piece of interest from like your treasury or something like that is like working in Aave. And then when someone basically when someone wants to recover, then I also receive a payment because okay, yeah, this is
just a bit more detail about it. It's something we just add. Actually, a guardian need to register. So we're gonna have a list of guardian. If you want to be a guardian, you're gonna register and you're gonna pay extra fees, like registration fees. It's gonna be very small. We don't want everybody. We don't want to. You need to have the app. So we need to know you because we're storing the list of guardians. In addition to not send a request to everybody. So you register to become a guardian, and then we're gonna contact you. And as well, like as you said, at the end, you're gonna get like your reward.
Okay, awesome. Yeah, I think this is what I understood as well. This is a very cool project, and I think it's even more interesting because it's like something that has tried to be solved in many ways, and I think that's a very original solution. So yeah, excited to see it scale.
Awesome, thank you. Well, we already have Natic coming in to talk to us just randomly. I think because we have the project and they like it, and we probably give us like a small help in the development. So we are working on it. We already have like a roadmap. So it's gonna be something that hopefully we can see soon.
Awesome, congrats.
Nice work, guys.
Thank you.
Thank you.
Awesome work. Thank you so much, Team Alchemy.
Of course.
Awesome. We found DigiU.Lab, so we're going to promote them right now, and they're going to be up next. Okay, cool. So I have instructions to share this video from my end. So I'll be doing that right now.
Hello, everyone. We are DigiU.Lab team. We are part of the DigiU.AI project, one of the top 3 crowd investing projects. Our goal is to create a cross-chain swap between Ethereum and Binance Smart Chain blockchains. BSC is a functional clone of Ethereum, but much faster and has a lower transaction cost. We create our own bridge between these blockchains. We use Chainlink to do that. In Binance Smart Chain, the only liquidity entry point is Binance. It issues its own tokens pegged to traditional tokens, such as Ethereum or USDT. Therefore, if you have USDT ERC20, you need to give them to Binance to get the pegged tokens for BSC. So, currently, Binance pegged tokens are used in BSC, and secured by Binance's honest word, as Binance Bridge is centralized black box. We see this as a potential problem that we can solve by providing people with decentralized and clear cross-chain bridge to swap their assets. So we create a decentralized exchange that uses liquidity pools in different blockchains and transmits cross-chain data using Chainlink-based bridging technology. It should be noted that this solution will work with any blockchain that supports EVM and Chainlink. Our prototype works similarly to the Uniswap protocol. Let's look at a prototype cross-chain exchanger. We have improved the user experience by using our application to simultaneously use the connection of 2 wallets set up on different networks. Let's do an exchange between Ethereum Rinkybuy and Binance Smart Chain testnets. First, let's run the approve. Please remember the balance of the pools. After the exchange, they will change. The operation of our pools is provided by 2 smart contract pools filled with liquidity. AAVE, Rinkybuy Network Test Tokens, and Uni-Binance Smart Chain Testnet. When the transaction is confirmed, you can click Swap. We need to accept the offer and confirm the transaction. It puts the AAVE token into the pool and initiates a client contract call in BSC blockchain using Chainlink. Now we need to wait until the transaction is confirmed. The connection or communication between the blockchains is provided by the 2 Chainlink nodes we deployed. When the transaction is confirmed, the node that is connected to the Rinkybuy will run the job. This job will initiate the sending of Uni tokens from the Binance Smart Chain pool. We need to use Chainlink token to call Oracle's Chainlink services. You can see this in the transaction here. Let's refresh the BSC Testnet Explorer page to see the incoming transaction. As you can see here, we've received the requested amount. Now we can check the received amount and compare it with the amount we've sent in the swap interface before we clicked swap. Also, you can see the change in the cross-chain pool balances. We've also developed an add liquidity operation. It uses similar principles, even though it's a bit more complicated. Thank you for watching our presentation. Feel free to ask your questions.
Very cool. All right, Bogdan, I'll turn it over to you. Feel free to share your video. There you go. And over to the judges.
Very cool. Yeah, like cross-chain liquidity, it's becoming clear we're gonna need lots and lots of bridges and ways to move between chains as we're moving away from kind of this single chain world. One question I had was, yeah, I guess I'm not as familiar with how Chainlink works. So is this basically using Chainlink to read the balances, kind of using Chainlink as the bridge to relay, like, oh, this has been deposited in one place, and sending that message to the pool on the other chain? Is that basically how it works?
We use Chainlink both ways. We okay, to read the data is the most simple way, but also we use Chainlink. We have wrote Chainlink script, Chainlink external adapter script, and it actually calls a contract method on another chain. So we have the whole mechanics working.
Oh, very cool. That's a kind of, I think, a unique.
And we have, for now we have the smart contract. It's the same. And no, our DEX pool smart contract is mirrored in both chains, and it have two methods. I mean, even the methods is the same. If you want, I can show you.
Oh, I think that's very cool. Thanks.
And it's working. This prototype, it's working. Just for one, for one token in the one chain and one token.
Yeah, and on Rinkeby. But still, that's awesome.
Yeah, that's quite nice. Congrats on the project. I was wondering, like, do you see this as like first step to bridge Ethereum and BSC? And do you have plans to build like other chain using the same? I saw in the presentation that it was compatible, but is this part of your plan or is this just like a statement?
No, sure. We want to actually we have plans to design real liquidity pool with mixed liquidity from different chains, and of course we want other chains to participate in it also. Okay. There is no limitations. Any Ethereum, any EVM compatible blockchain, we can configure it and it will work.
Nice.
Awesome. Yeah, I echo what David said around just having more cross-chain bridges. I think that this is awesome. I'm just curious, like, what do you think was technically the most complex part of this implementation?
Actually, the most complex thing is in front of us. Is to make this decision decentralized, because in this prototype, what we showed you, our cross-chain, this external adapter, which runs on the Chainlink node, it actually becomes a single point of failure, So there is no in this implementation there's no decentralization. But what we are thinking now is to make such adapter that it can become really decentralized, that we can let anybody to run it, and it should be trustless. And we have thoughts how to do it, but didn't implement it yet.
Yeah, that makes sense. That's definitely.
So this is the most complicated, because in my level of understanding of Chainlink now, that what do they sell? At the moment they sell price feeds, but price feeds is a little bit different. You can for example, you get in prices from 20 nodes, and you can see that maybe one node is malicious, and you can throw it out. It's okay. But our goal is to make changes on another side. So we have to do some like protocol, like how adapters should negotiate between each others, or it's one way. Or second way is maybe to embed it into Chainlink code. So there's a lot of different ways to implement it.
Yeah, for sure. That definitely sounds quite complex, but I think what you've done here was awesome, and I'm looking forward to seeing where you take this project.
And actually, you can test our web application, and there is two facets in the right upper corner. You can press facets, and you just need to add token into the wallet.
Awesome. All right, we got to wrap up here on this one, but thank you, team DigiU.Lab. Awesome project. Thank you. Excited to see the future for that one.
Yeah,
thank you very much.
Yes.
Okay, cool.
Congrats.
Up next, we've got Team Hush Hush. So I've already promoted you guys. So feel free to share your audio or your video with the audio button checked. And I'll turn it over to you.
Start with presenting Hush Hush, improving anonymity on savings accounts. So the problem is that we want an on-chain savings account, but just having 8 tokens in a wallet is not private and it leaks a lot of information. We could put 8 tokens into a Tornado Cash pool. That would be great for privacy, but it's very inconvenient if I want to continuously use from it. So say I want to deposit $1,000 and then withdraw half of it at some point. I cannot do that. Our idea is Hush Hush, which is a sort of Tornado Cash with a twist. We have fixed deposit amounts, but variable withdrawals. So we're doing this exactly how the same manner as Tornado Cash is, by using CK Snarks. And CK Snark is really just a proof that something is true without showing you why it is true. So to deposit, we don't have to provide a proof. The user simply provides some secret knowledge, which is K, and then the contract computes a leaf and inserts it into the tree. And then it pulls funds from the user's balance. So the first part of the withdrawal is what do we actually need to prove. So to be able to make this continuous deposits, we have to provide a change leaf that is inserted into a tree, and then we have to prove that we know all of the secrets for our inputs, and that we are not creating any funds out of thin air. And to ensure that we cannot spend the same funds multiple times, we provide a nullifier. Beyond just what we have to prove, we also need to think about how we can publish the proof. So if the user publishes the proof himself, it destroys his privacy. But we have to keep in mind that regardless of who publishes the proof should be valid. So we can have a relayer do it instead. And then as we're having a fee inside the withdrawal, we can have this fee go to the message sender, meaning that if the fee is larger than the transaction fee, it is an easy arbitrage. And then we also need to recall that because we're using a snark, the publisher cannot change any of these inputs without it validating the proof. So Tornado Cash has better privacy, as it is more limited on what users can do. And then we also have an issue of we cannot run in the browser currently because of some issues with Snark.js. For future work, we would like to have publish encrypted versions of leaf contents, just to ensure that people are not throwing away their funds. Set up a network of relayers, and then have in-pool transactions. And then we have a small demo.
Awesome. Turn over to the judges for questions.
Nice, great job. Yeah, I think this is probably super complex to do. I think it's a pretty glaring gap, at least in my view. I think the transparency of public blockchains is both a blessing and a curse. So I think this is a really useful thing that you've built. So awesome job. I'm curious, how much gas do you think this would cost to do a withdrawal on Ethereum L1 today?
So it is really expensive, especially so the hash function we are not using SHA-256, as that is very inefficient inside the snark. So we're using MIMC, and then depending on the depth of the tree, you're using around 50,000 gas per hash. So say the tree is the same size as Tornado Cash, so 20 step deep, then you're almost around 1 million gas. And then for the withdrawal, you're also having the snark and withdrawing the A tokens themselves. So, and we also had to make a calculation. So because inside the proof, we have to have a specific amount, not an amount that is changing over time. We're using like this, we're using this scale balance of the tokens. So we also need to take the scale balance, compute how much would that be in current balance, and then withdraw that from the pool. So it is currently very expensive to do. So we thought about making some of the verifications, move more of the verifications inside the snark, but then we have some issues as then you have to be the next transaction. If the state has changed, your snark will be invalidated, and that would not be that nice. So you would be around like 1 million gas to deposit, and then just a bit more to withdraw. So it would be fairly expensive.
Yeah, which for some users that's okay too. Like if you have a large enough balance and you want privacy, maybe you're willing to pay for that. If you were to build on an L2 today, which one do you think you do it on?
So I think for something like this, it would make sense to look at something like CK Sync or talk with the Aztec guys, as you could have recursive snarks. So you have pretty much a roll up of the snarks. So you just validate that on the main chain, which would then be, just the snarks, so around 3 million gas, and then you have a set of nodes that will make the like off-chain commutations.
Yeah, I think, just congrats. That's a very cool project. I don't think the gas is that an issue. Like Dmitriy was saying, like potential user of that would be large accounts. So for them, like gas is not necessarily an issue. I would not like put that as the main focus. The gas optimization is always cool, and that's like
the gas is pretty close to Tornado Cash, so I think it is sort of like the same user base as well.
Yeah, and I think it's a very cool project. Yeah, congrats.
Yeah, this is very impressive. In terms of the cost and stuff, I feel like, especially when it comes to zero knowledge stuff, this stuff tends to advance kind of exponentially. And so I imagine stuff that's expensive and difficult to do today will be, a year from now, quite easy. Can you just talk a little more about the cryptography side of it? I mean, I'm not a cryptographer at all.
Okay, so the state is pretty much just a Merkle tree. So when you make a deposit, you don't have to make a proof. You are inserting into this Merkle tree, and then so we use an incremental Merkle tree, meaning that when you insert, you pretty much compute the path to the leaf, and then you insert the new leaf.
So you submit like a proof. Do you have to submit a proof or?
Yeah, it's not really a proof when you submit. You just submit the new leaf, and then you insert that.
Oh, it's just a leaf. Okay.
Yeah.
Because is the whole tree stored on chain, or just
the tree is some of the values are stored on chain. You need enough values to have some of the intermediates to make it easy to compute, but you don't have to have the whole tree on chain.
And isn't it possible to work back the balances by the interest accumulated? So like maybe you could get doxed by the interest that you accrued.
So the idea is that the withdrawals themselves are anonymous, but you can see who deposits in. So say that if you're the only guy who deposited in, then really easy to figure out who you are. But you could also just withdraw some of the funds at a time, and then it'd be fairly hard to see if, say, 100 people have deposited $1,000 and somebody withdraws 200, then it's fairly difficult for you to see who it is. So that is also why we have limited to a fixed amount that you deposit. So if you have to deposit the same scaled amount. So say that at one point the deposit would be $1,000, then at a later point, if you have to deposit, it would be 1,100.
Okay, yeah.
Very cool.
Yeah, you should create like basically a private market on the Aave protocol.
Very cool. Awesome. Okay, thank you, Team Hush Hush.
Yeah, thanks so much.
All right, we're going to move on to Team InterestSimulator, and I have a video from Anna that I'll play on her behalf. All right.
Hi, my name is Anna, and I'll be demoing the Aave interest calculator for you today. It's a simple tool designed to quickly estimate how much interest you would have earned if you were to deposit an asset on Aave version 2, or how much you would have had to pay if you also decided to borrow against it. So here we go. This is all powered by the graph, by the way. Here we have the graph. You can quickly see that there's definitely periods where you don't earn much interest at all, and then there's jumps and you start to earning interest more regularly. This is specifically for the BAT. Let's go for a different asset maker. So here we can also see that by the end of 30 days you would have earned about $100, and we can also definitely borrow against it. Here we go. So here, if you borrowed 100 TUSD, the interest has lowered, but you're definitely still earning interest. And if you borrowed a bit more, you're going into the red territory, and you would have started owing interest on your loan. Here, it's actually a little not intuitive that owed interest is still higher. That's because it's not normalized. So if we switch to USD, you can see earned interest is higher. There's also the rate portion. You can see the rate is highly volatile. This just gives the user better understanding of the ecosystem and which assets are more volatile, which are less. If I had a bit more time, I definitely would have loved to integrate a wallet and read all the assets that the user already owns, and show them the accumulated interest they would have earned, and maybe even just having multiple inputs for the deposit so they can also do that manually. Thanks.
Awesome.
All right, turn over to the judges. Yep, there you go.
Yeah, it's congrats on the InterestSimulator. It's really useful. I know that a lot of the user in DeFi and in Aave particularly are always eager to make those simulation before they make some deposits, or after, to just like see the opportunity loss or like the potential gain. So I know that this has like already a market that is not yet really tapped in. So yeah, congrats.
Thanks.
Yeah, this makes me think of, I have like a APY vision like pinned in my tab, which is like Uniswap stats, and I'm like always checking that. And I feel like if this was live, it would be pinned right next to it. It's like, check my Uniswap, check my Aave. Super useful tool. You got any thoughts or ideas about adding other protocols? I imagine this would be useful for kind of any lending or interest-bearing protocol.
So far it's just on Aave. I had a hard time coming up with an idea, to be honest. So I just went off one of the RFPs that Aave had on their website. So yeah, definitely an opportunity to integrate other protocols, and yeah, that's not an issue.
Awesome.
And what was the most challenging part in building the InterestSimulator?
I think I had a hurdle with the actual formulas for the instantaneous interest, because the documentation is a little misleading. And yeah, just reading the graph, because the historical data is limited to like 1,000 entries. So just figuring out the graph for that and learning.
Awesome. Don't hesitate to keep in touch to explain like the what part of the documentation was not really clear.
Okay.
Thank you. Congrats.
Yeah, this is awesome. I would echo what what David and Jordan said. I think in general, users in DeFi just need more analytics and tools because I feel like they often just don't know what they're getting themselves into. So this is great. On that formula part is part of that difficulty, and I'm not sure if this is true, but this instantaneous interest or like the fixed rate isn't actually fully fixed, and so it still kind of like fluctuates. And so is that part of the difficulty with calculating it, or was it something else?
No, it was just a technicality, making sure like my rates are matching Aave's rates.
Got it. And a really small point, can you adjust the date range? Because on the UI, it was last 30 days.
Yeah.
Is there flexibility?
So right now, yeah, it's only 30 days. It's another thing that you can easily adjust and add on to the project if I had more time.
Awesome.
Is this live anywhere?
No, but I can make it live.
You should do it. Like I want to use this.
Yeah, definitely make it live. We will promote.
Yeah.
Great work.
Thanks.
Great job.
Well, if Aave promotes it now, you've got to make it live. You don't have a choice. Okay, awesome. Thanks so much, Anna. And up next, we have Quickzap, and then we're going to take our longer break after that one. So Team Quickzap, if you could raise your hand if you're in the chat here, that would be helpful. All right. There we go. Awesome. So when you're ready, feel free to share your screen and tick that share computer audio box. All right, let's take it away.
Project is called Quickzap. Quickzap is a DeFi payment gateway. It's the easiest way to make and accept decentralized payments from customers anywhere in the world. To make use of our API, you just need to click on the Get Started button. You could copy and paste the API in your code and then load your page. Now, this is a sample page on how the API works. Like, I want to make payments for this shopping cart. All I need to do is to click on the Pay Now button. Then it pops up. I connect to my wallet. We select the token. We select the token type one you use to make payments. Then I click on Pay. Then I've made payment, which shows you how you can use any form of ERC20 token to make payments at any store. Now, we about 3 in our team. These are the team members that made Quickzap.
Okay, cool.
Yes, that's the presentation.
Yeah, we'll turn it over to the judges for any questions.
Great job, Sam. I think the more fiat on-ramps and the more you could connect DeFi and crypto to I guess the traditional economy, I think that benefits the whole space. So really important work here. I'm curious, what does the merchant have to do on their side? Well, is there anything that the merchant has to do to accept a payment? Does it have to convert to fiat on their side, or do you have a sense of like how you'd want to build that out?
Okay. For the merchant to make use of to receive payments, all what they need to do is just to copy and paste the API. So there's no to make it more easy to implement. So they don't need to make use of any API key. So what they need to do is just to copy the code snippet and paste it in their code, and they pass in the amount and they pass in the token type they want to receive payment. Probably maybe I want to receive payments in half, or maybe in any form of ERC20 token, or in a stable coin. So then I set the token type. So then once I put the code in my website or in my app, then by the time I load the page of my app, when users comes to my store, they want to purchase something, they can just click on the pay button and it pops up. So they select the type of ERC20 token they have with them to make payments. So we're actually planning to roll this out for public use. Right now, we're working demo already. So the goal is also to include other in the future to include other blockchain technologies whereby you could switch from maybe Ethereum to Polkadot, from Polkadot to just having combination of all the tokens and coins in one place, right? So they can use it to make payments. So just like, for example, now I need to do something in some emergencies whereby I have some tokens where I can use for my day-to-day activities. So that's what came up. That's what brought up the idea.
Got it. Okay, great. Thank you.
Yeah, congrats also on the Quickzap projects. I was wondering, have you thought about using the interest-bearing stablecoins? So instead of using DAI as stablecoin, using ADAI, so that your merchants have directly interest-bearing treasury, since it's always one-to-one to the underlying. Is this something you thought about?
Yeah, we've thought about it, but because we thought about it also but because of the time was not enough for us to make the development, so we're trying to rush. So our plan was to use Chainlink to get data for the currency conversion, making use of building a Chainlink API, but we didn't have that time to integrate that. So we saw that it was already close to the dying minute, so we just had to quickly rush up.
Yeah, okay.
This.
Very cool.
Thank you.
Awesome. If that's it, thank you, Team Quickzap. All right, awesome. So we're going to go into another one of our breaks. Thanks again. Basically, judges, just to give you an idea, we'd probably take a couple, maybe 5 minutes or so, kind of stretch your legs. Feel free to jump into that side call if you'd like, if you want to mute here and go chat there, if you want to exchange answers so far, but good opportunity as well to sort of see how everybody you've seen ranks so far. And we've got 4 more after the break. All right, see you all in about 5 to 10 minutes.
Cheers. Yeah.
Hello, everybody. Getting ready to get back into it.
I am, yeah.
Awesome. All right, looks like we're all here. I'll share mine too. There we go. And another corner of David's apartment. Very good.
Back to the first one.
Very, very good. All right, cool. All right, so like I mentioned, we've got 4 last projects up next, last but not least. In terms of next projects, we have team xCFD, which is Nathan. So I'm gonna invite Nathan up to right here. And Nathan, I'll be playing your video. All right, we'll let Nathan get all set up. All right, and here we go.
Hey, welcome to the demo for the beta of xCFD. It's a decentralized protocol for buying contracts for difference on Ethereum. You can learn more at xcfd.org/docs, but I'm just going to jump right in with a demo. If you want to learn more about how what I'm doing works, you can just read about it here. So I'm going to go launch app in the top right. That'll take me to app.xcfd.org. I'm going to click buy in the top right here. So I'm going to get ready to buy contract. But the first thing we need to do is connect an Ethereum wallet. So I'm using MetaMask for my wallet provider. It's a browser extension. It's free. I highly recommend it. One important thing is to make sure you're on the Coven test network if you're replicating this yourself, because it's not on mainnet yet, mainnet, but I will put it on mainnet in the future. So I'm going to go ahead and click connect wallet here on the top right. There will be a little pop-up window. It's going to make me sign, or not sign, but connect MetaMask to this website. So I'm going to click next, and I'm going to click connect. Yep, looks good. Connect. Okay. So we're good. And if it works, might have to refresh the page, but it should have your wallet address, or at least the first part of it here in the top right. I'm going to click buy, and I'm going to click February 14th, because it's not February 14th yet. Important thing about setting an expiration date is for your transaction to go through, you need to make sure it's a future date. And CFDs expire on 10 p.m. UTC, as per recommendation of UMA documentation. And UMA, by the way, is one of the primary protocols I'm building this app on. So without further ado, we're going to click, looks good. Ether, by the way, is the only token that's supported right now, but so we're going to place order, and we're going to click confirm transaction, and I'm just going to check the console to make sure everything looks good. Yep, so we have a contract for difference on Ethereum now. That's going to expire on the 14th. So that's it in short. There's a lot more that needs to be done here. This is kind of a partial / incomplete demo, but I figured it's better than nothing. I'm going to be working on this a lot. I'll be active in the UMA Discord and be pushing updates for this, and hopefully launching a mainnet V1 as soon as possible with many more features. I was pretty busy this hackathon, but yeah, I think we got a lot planned for the future. So thank you for your time watching this. And if you have any questions, you can always let me know. All right, thanks. Bye.
All right, awesome. Turn over to the judges.
Yeah, I think congrats. CFD is like one of those primitives that is a bit missing in the current space. So yeah, glad to see someone to building it. Like, what was like your main challenge in building those?
Yeah, I would say just the implementation. So like, there's a lot of ways you can go about doing it, but ultimately, I'm just trying to like not only build new financial projects, but also like migrate old ones, existing ones that people are already familiar with, to the DeFi ecosystem, because it's just good for adoption and just be cool to see.
Yeah, do you mind just giving me like a 1-sentence overview, like what is a CFD?
Yeah, so it's like basically an agreement between the investor and broker to exchange the difference in the price of security between the time the contract opens and closes, with like a set expiration date. And usually there's options to like roll that expiration over, but I haven't implemented that yet.
Gotcha, that makes sense. Thanks. Yeah, very cool. And always good to have more of these primitives, right? Like, we're pretty much going to port over every primitive from the traditional financial system to this.
Yeah,
so
be cool to see.
Awesome, nice work.
Yeah, really great to see more folks building on UMA. I'm curious, is this a purely peer-to-peer model, or is there an order book hosted somewhere for these CFDs?
So this is actually using the price feeds through UMA DVM, which is like basically one of their oracles. So yeah.
Got it. And could you walk us through what happens at expiry?
Yeah, so essentially, if there's not over 120% collateral, so like the contract will get automatically liquidated if collateral exceeds a certain amount, but basically if it's out the money a certain amount, but otherwise it'll actually just go through to expiration, it'll automatically liquidate. So yeah, that's the cool thing. It's like basically contingent orders without the user having to confirm a transaction at expiry.
Got it. And how does it, well, wouldn't you need bots to trigger the liquidation, or is that not necessary in this model?
Yeah, so when they sign back in, they'll have to confirm something, but yeah.
Got it. Okay, cool. Yeah, this is awesome.
Yeah, a lot more work to do on this, but yeah, it was a cool little demo. I thought I'd submit it anyway, so yeah.
Yeah, no, for sure. And I yeah, like Jordan said, I don't know of any other projects that are live doing this. So that'll be fun to kind of get it out in the open and see who's using it and get some feedback.
Yeah.
Nice.
Okay, cool. Awesome. Thank you, Nathan. And we will move on to the next team. So up next, we have Aave-Teller-Machine. So Chris, I'm going to bring you over now. And Chris, when you're ready, feel free to share your video with the share computer sound ticked.
Hey guys, how's it going? All right, and I'm going to share my screen here really quick and share sound. You guys see everything?
Yeah, that's great.
So yeah, I'll just kind of walk you through this really briefly. I have spent the last couple weeks working on a thing that I call very lovingly the Aave ATM machine. The Aave ATM machine is actually physical cash liquidity provision. So in my hand is a $100 bill. But we'll talk about how this becomes $100 in DAI here in just a moment, or a DAI actually. So anyway, let's show how this works. What I have is a actual physical ATM machine made by a company called GenMega. GenMega makes most of the ATM machines that you see in bodegas and other places in the world. You know, you just see one in the club, the one that says "Get Cash." You know, that's a GenMega. So if you've seen it, that's the thing that I have, and I'll show you guys here in a moment. I've reverse engineered all of the functions of the ATM machine, the pin pad, the cash dispenser, the bill acceptor, the screen, all this stuff to basically make it an Ethereum contract front end. So the team is me. Hi, I'm Chris. Yeah, I'm actually a very good hacker. So I should actually say that first. I'm internet famous for being one of the first humans to jailbreak the iPhone. So embedded engineering is something that I get like very well. So yeah, let's talk about a couple of the use cases that this machine does, and then I'll actually walk you through physical liquidity provision. So in this case, we've got an Alice and Bob. This is an ATM machine at a bodega somewhere in Brooklyn, we'll say, not too different from where I used to live. And Alice is a bartender at the Levy, and she's got about we'll say $100 in cash. And she's walking over because she doesn't want to like ride the L train. And with that cash on hand, because people are weird, especially nowadays. So walks into this bodega and physically sees, this Aave ATM machine. In this case, actually, let me go ahead and let me do the physical. That's that one. I'm just, the slides are out of order. So she walks in, deposits $100 in cash inside the machine. The machine also has a adjacent smart contract. The smart contract has the shop owner who owns the, let's actually rewind a bit. You have an ATM machine in a bodega. One of the most important things to understand is that the shop owner also owns that ATM machine. It's just like the teller that they have on the counter. The cash that's inside the ATM machine is equivalent to the cash that they have on the counter. It's basically one treasury all the way through. So what I'm proposing here is that, and it's actually the ATM, the cash that's in there, about $4,000, is sitting there not connected, doing anything. Now I have some better ideas on what to do with that in the future, but like for this use case, I'm just saying, for now, the shop owner also puts up, let's say $1,000 in ADI liquidity. And so what ends up happening is when he gets a physical $100 bill, that is displaced by the ADI and pushed into the contract. So and we have it working two-way, the ability to put cash into a machine and the ability to reclaim. And so without further ado, oh, and then I'll also, let me go another use case. One of the options that I could do is use physical liquidity providing as a way of doing a remittance transfer, if you will. So I can provide cash, again, the same story that we just had, but assign the credit delegation to someone else, maybe my abuelita in El Salvador. And so this is a way in which to provide really interesting, potential cross-border payments. Again, this is cash that exists on both sides of the ATM, and it's simple software and an upgrade. So without further ado, I'll just like roll my laptop into the next room. And here is an Aave ATM machine. Now, I've got it set up right here. I'm going to deposit some ADI, but I can, let me just go ahead and show the physical cash work through first. So here, $100 bill. I'm going to go to my bill acceptor page here. Open this up, allow, open, and initialize accept bill. So now here, I don't know if you guys can see this. There's my accept bill. Open. Hold on, guys. Reload, of course, like every fucking demo. Let's do this here. Crazy thing about ATM machines, they run COM components. No shit, guys. I've had to reverse engineer so much stuff in classic Windows COM, but yeah, like I've got bill acceptance return. Let me go here. So accept bill, initialize, accept bill. And there we go. Open, initialize, accept bill. Come on. Oh yeah, now it's green. Woo! See that? It's green now. I push that in. I get a live bill accepted notification. That dings an internal smart contract that I have here. And that just pushes DAI directly to the wallet address that I have paired up here. So when I go look at my physical wallet now, once that happens, a transaction notification happens. And basically in Ethereum time, it'll take a little bit, but the human can just sit there and they don't have to be in front of the machine to physically interact with it. And so, yeah, I'm basically working on all of the components of the cash acceptance and payout. And while I've got you guys on the phone, why don't I just do this? Let me introduce you to the Aave ATM bot, which is here. Let me just paste if you go to Telegram.
I want to make sure we have time for questions as well. So
no worries, no worries.
8 minutes total, and I think we're already at about 7. So,
all right, well, let me stop my share. I'll go here to the chat. I'm gonna paste this bot there. If you go into it, and one of you guys sends a /dispense notification to the chat, you'll see it'll spit out $100 here on the other side of the machine. Just connect, slap.
Yeah,
there we go. All right, cool. Judges, do you want to ask a couple of questions real quick?
Yeah, for sure. I mean, in general, I love the name ATM. I get it. And I applaud you on the bravery of doing a live demo, especially with a hardware machine. That's not easy. Yeah, I feel like I have a ton of questions and there's not enough time to cover it. But can you just clarify the workflow for me again on the deposit?
We'll say Bob is the shop owner, Alice is the depositor.
Right, but so when I deposit, I go to an ATM and I deposit, do I need to specify my public key A and B?
So no, it uses Wallet Connect. I didn't show you guys, I didn't show you that part of it, but I can show you that I can connect with Wallet Connect, and it just, that's how it gets the address.
Got it. And from which account does is the DAI pushed from?
From Bob's, the shop owners.
So he needs to first top up that account with.
Correct. And he'll have notifications as to how much is inside his wallet. I mean, you know, it's part of the running a crypto ATM.
Got it. Awesome. Thank you.
Cool.
Yeah, yeah.
I'll give Jordan a question just because I'm sure he's never seen an ATM running his software.
Yeah, it's like it's fucking crazy. Like awesome, Chris. I have like many questions as well, like everyone else.
I mean, feel free. I'm around all day.
Yeah, I think
I'm working on this stuff.
I think we'll contact, but
yeah,
maybe just one. Like, do you always got like an ATM lying around in the garage, or?
Well, I mean, so the fun part about this is I was actually tapped by a group that does this right now. They actually manage physical ATMs in stores, and these are actually the ones you're most commonly used to. So I didn't show you this part, but I've also reverse engineered these two. But that's a bigger story. Anyway, yes, basically with the code modifications that I've made, my software can run on, I would say, 80% of the world's international ATMs and make them crypto ATMs overnight.
Awesome. Yeah, I have plenty of questions and even ideas. So
for sure, I'd love to talk to you guys about them too.
Amazing. I was going to ask if some bodega knows that their ATM is missing.
Yeah, it's like, you know, but here's the thing: imagine a bodega like like currently this is a cost basis for them for the most part, and now it's a thing that can actually give them, you know, yieldable money. Like there's like when we get into the remittances market, you see how big that is. You get into the just the ATM fees market, a free ATM, like an ATM that has no fees, like except for the Ether ones, you know. Anyhow, that's it.
Very cool. Chris, thank you so much. This is sick. And yeah, I mean, hope to see one in a bodega near me.
Let's hope so.
Thanks, Chris.
All right. Take care. Okay, cool. Up next, we've got Team Fanance Club. So feel free whenever you're ready to share your screen and computer audio, and we'll turn it over to you.
Sure, we are up. I'll play the video now. Greetings, we are Team Fanance Club here to present our project. The problem we are trying to solve here is that many people around the world are hesitant to invest in the stock market or cryptos due to lack of knowledge about the assets, hence reduced financial inclusion around the world. But all of these players or users have a lot of knowledge about their favorite sports and their favorite sports stars. So we want to build a platform where users can trade their favorite players, thereby getting an ROI for their income using cryptos. Now the platform is being built as an ERC20 exchange platform where each of the celebrities or the sports stars will be listed there as an ERC20 token. The users will be able to buy and sell these tokens for a particular price. The price of the sports players will purely be determined by the supply and demand for that player. For example, if a player is predicted to be doing well in the next match, the price of that player will increase and so on. Now, the platform is being built using Ethereum and Layer 2 Matic. We are also identifying opportunities with Aave Wasabi after attending this webinar by them. Let's take a look at the demo of our platform. The demo has been launched in dap.fanance.club. If you go to the home page, we'll have 5 different players and 2 different sports here for the MVP. Now, any of these players can be bought and sold from the exchange trading page. When I look at the wallet, this is where Matic comes into picture, where Ethereum from the Ethereum network can be converted into Matic Ether tokens automatically using the Matic widget that we have used. But let's take a demo of the actual exchange trading page itself now. Looking at Mahendra Singh Dhoni, he is a favorite cricket player in India. So this player will be listed here. All the buy orders and sell orders and the trades will be listed here. Now when I go to some other player, the entire history of that player will come in. So when I want to, let's say, buy one of these tokens, I can either click on here any of the sell orders and fill that, or I can enter that manually as well here. So if I want to fill this sell order, I can buy, and it opens MetaMask automatically. So currently it has been deployed into Ring-B test network for testing purposes. Soon we'll be launching under Matic mainnet. So once I confirm this order and the order gets placed and confirmed, you can see that this sell order gets executed. Once the order is cleared, I can also see that in open orders and history. Now that the confirmed transaction has been confirmed, I can see that the 100 tokens that I have bought for a price of 0.00013 has been filled. And also there will be a change in my candlestick chart automatically. So today there is an open of 0.0001 and a close of 0.00013. So this is about our platform. One of the most important questions that we get when we talk about this platform is about the licensing. So Fanance Club is a game of skills rather than a game of chance, and hence when you are predicting a user's performance in the future, it is not like a lottery where you take a game of chance, and hence we won't face any of the copywriting or licensing issues from the players. Even if it comes, we have a reserve fund that will be maintained for all the traded sports stars, so we'll be able to pay them a royalty based on the reserve fund. The future work that is in progress is mainnet launch on the Matic network. We are planning to use Bioeconomy for gasless transactions. We are launching our own token, which is used for fee payments on the exchange platform, and integration with Chainlink and integration with Aave Wasabi is also in the works. That's Fanance Club, and you can check us out at www.fanance.club or dab.fanance.club. Thank you.
Awesome. Turn it over to the judges.
Yep, thank you.
Very cool. One thing I wanted to say is like I love the UX. The whole UI looks really beautiful. Did you guys build that whole UI just in these couple of weeks? And can you say anything about the front end side of this project?
That's right. I've used React.js and Drizzle, which is a Truffle component for getting all the contract-based data. So Truffle plus React is what is running here. I'm also planning to use Firebase to store the user's email ID and nickname for the user so that I can show real-time updates on who's buying the tokens, who is selling the tokens. That will add more excitement to the players. We are also using APIs given by Cricinfo and a lot of other sports websites to update real-time scores of tournaments and current matches. Also, we are planning to play live commentary in our platform very soon once it is launched.
Awesome. Very nice.
Thank you.
Yeah, awesome. Congrats on building this so fast as well. Like, I always love this kind of like human tokenization because it works both as like representation of the presence for all the sports, but also like kind of like prediction markets when we expect things for different basically sportsmen. So yeah, it's like how do you see it scale? Like what would you be doing in terms of the, I guess like there is like even like business model behind it. So like where do you see it taking?
Okay, the first place where we get the revenue from is through an ICO. For every new player that is launched, there are going to be a few tokens which are maintained by the company as a treasury for the royalty. And in the future, we are also planning to bring in complete decentralization of this, where users themselves will be able to tell us, recommend some players which they want to see in the platform. And when they launch it, when they create that token, they get a portion of that as well. So that's the first part of the revenue. Second part of the revenue comes from our fees. Every exchange trade that happens will have a 1% fee, and that will go to the ERC20 token owners, and we are going to split that as governance and things. So that's how we have planned the entire revenue. We also have our own fancy token, which can be used to pay fees. It's like BNB tokens on Binance. So if you pay using the base Ether, you pay a lot of fees. And if you pay using BNB, it is 50%. So you can either pay using Ether or fancy token. Fancy token will be half of Ether fees. That's how we have planned the revenue here.
Cool. Yeah, I agree with David. Really like the front end here. Really beautiful. How many instances of each player will there be?
Okay, we are still working on the tokenomics part of it. How many tokens have to be launched for a particular player? So, for example, Cristiano Ronaldo, should he have 1 million or 10 million tokens is a question that needs to be resolved. Probably all the people I've got from Discord using this MarketMake can help me get into this tokenomics part of it. But for now, I've set it as 1 million to curb the supply.
Oh, got it. Have you considered then using like an ERC 1155? Or does that introduce difficulty with trading these things?
I've looked at ERC 1155, but I've not decided whether I have to go with that approach yet. So I have to do a lot more research. For now, it is ERC 20, but shifting into ERC 1155 is not going to be a difficult task as well. So that can be done if required for sure.
Got it. Yeah, because that might introduce some scarcity.
Definitely.
And then just a comment, I think fee tokens, they add friction to the UX. And I think if you could have a model where you accept payment as in ETH or stablecoin, and then you still have the governance token, and then have a portion of that go to a treasury that's controlled by the governance token, that's a much smoother UX. And I would just encourage to look at that, because I think a lot of the payment token models from around 2017, it hasn't really worked out and it hasn't really accrued value. So I feel particularly strongly about this. So I would just encourage to look at ways to make it as easy for end users, and especially here, which are probably more retail, to actually use the platform.
Sure. We'll look into that, definitely. Thank you. Thanks for the feedback.
Yeah.
Jacob, you're muted.
Oh man, always once. Thank you so much, Fanance Club. Really
Thank you.
appreciate the project. And I almost made it to the last but not least, we have HelloToken FlashLoan. So yeah, when you're ready, hopefully you shared the computer sound, but you can take it away from here.
Hi, just a minute, I'm sharing.
Yep.
Hello, for the hackathon, I have taken a simple thing called FlashLoan, which is already, the code is there. I'm just using the logic to unwrap it. So I'm using the whatever the tutorial has said. Now connecting the project, my Hello FlashLoan project, connecting to this with the local Ganesh, and maybe I'm setting up the Aave loan flow. This is the lending code address. Then now I'm going to deploy the FlashLoan version 2, which is this one. So I have all these codes in this directory FlashLoan, which is it contains this contract version 1. So I'm going to deploy that. I'm still learning about Ethereum and Solidity, so it is like a first hackathon for me. And this is the contract for the Ether wrapper, WETH, which is a wrapper of Ethereum. The contract. So I'm setting that as a thing to make a flash loan. So and I'm calling from the account 0 to transfer, requesting to transfer 1 Ether to the thing. This is the transaction ID. So now 1 Ether, one Ether is of WETH is transferred. So flash loan is executing. So this is executed. So we have to introduce, as per the documentation, we have to introduce the document. Here, we have to use I'm planning to use 1-inch protocol to get the price. Step here, what I will do, get a loan from Aave, and then unwrap the Aave WE, then swap that with the 1-inch protocol then with the die. Then again keep the swap with 1 inch protocol to the ETH, then wrap it again to WETH, and then pay back to the pool. So then what we will have? We will have an arbitrage of from this steps. So this is what I'm trying to do. This is I'm using Combo as a test. I'm impressed with this, and I wanted to do similar project since I'm not having some time and so I have come up to this. Thank you very much for your time, judges. Thanks a lot.
Okay, great. Turn over to the judges.
Hi.
So the idea is that you made like a way to have like a simpler way of making flash loans, right?
Yeah, that's the idea. Like I'm just trying to understand. Flash loan is very fascinating to me now. Start with
Cool. Yeah, flash loans are like one of my favorite features of
Yeah.
DeFi. Do you think this? Do you see this stuff you've been working on as mostly for? Looks like this was for arbitrage, but do you have any interest in kind of using flash loans for things like other uses like rebalancing, collateral pools, or things like that?
Yeah, initially, what the arbitrage is the biggest thing actually, which I want to do, because since from one exchange to get loan from Aave and convert that and sell get it from one exchange and sell it to another, between there is a arbitrage, right? So recently somebody exploited as for some $360,000. So I'm just trying to find what is the gap, how it is, just till I'm exploring. And then the other motivation is I want to make it like a Furrow combo, easily anybody can, even if you don't know coding, you should be able to assemble your flash loan with scratch like of blocks, like a Blockly from Google's. They have a Blockly thing, right? I want to make it something like with a block. Now every kid also know the scratch programming. So with that is another way, like instead of having a big stuff, like make it a simple blocks, like Lego blocks, so that anybody can understand, like it's not like a rocket science. So that's one of the aim to take it forward.
Very cool. Thanks.
Yeah, really glad you're kind of diving in and playing with Ethereum, and it's a learning curve, but I think this is a great start. I'm curious. It looked like you were using 1 inch for to fetch an Oracle price.
Yeah.
Any rationale on using that versus the Uniswap V2 TWAP?
One thing is the gas fee is very less. That's the promote. The other thing is I want to have a I will use the 1 inch as well as Uniswap, and then compare whichever the best price. Then so that you can make a little bit of money in that. So that's comparing the Oracle. 1 inch is one of the basically I want to try what is if there is any gap between various different oracles. So that's one of the motivation.
Awesome.
Congrats. And
Okay,
if
great.
you have like, oh, sorry.
Thanks a lot. This is my first hackathon, and blockchain. So I'm excited.
Yeah, I think it's very cool
Thanks a
to
lot.
see you learning Solidity through FlashLoan. I think that's
Yeah.
you start at the right point.
Thanks a lot. Thanks.
Definitely.
Okay, cool. Awesome. Thank you so much.
Thank
And
you
with
so
that,
much.
we are all wrapped up on all the projects for this group. So thank you everybody for coming out. Thank you everyone who demoed. As mentioned, this is part of MarketMake. We're in the final days here with our finale on Thursday. We will be showing off some of these projects and projects from other judge rooms as well. So keep an eye out for that. That's Thursday at 12 p.m. Eastern time. And yeah, big thank you again to our judges. Thank you to all the people who came out and demoed their project. And we will catch you at the next ETHGlobal Hackathon.
Yeah, thank you and congrats everyone.
Thanks everyone. Thank you for coordinating.
Yeah, this has been fun. Thanks to and thank you to Jacob as well and all of ETHGlobal for organizing.
Yeah, thanks everyone.